All right, we are moving on to 8.3, the second lesson of the trigonometry unit. We are going to be talking about radian measure. Um, so I think I gave you a little bit of a preview last time. Radian measure is simply just a different unit when we measure angles, okay? So in the past, we always use degrees to measure angles. That's the unit, right? 50 degrees, 90 degrees. Today, we're going to be looking at a different unit, and we call it the radians, okay? So but before we do, we're gonna do a quick review of what we did last time. So here it says point P, negative 3 comma 5 is a terminal point of an angle in standard position. So we're gonna quickly draw that. Negative 3, 5 is somewhere here. Okay, so here's P, 90 degrees. Determine the exact values of the 6 trig ratios for theta. So here's angle theta. This will be 3, that's a 5. We can find the hypotenuse side by taking the square root of the 3 squared plus 5 squared, okay, using Pythagorean theorem. So here's my r. That would be the square root of 5 squared plus 3 squared. So that's root 34. Okay, so this is root 34. So now we can figure out the ratio for sine, cosine, tangent, and their reciprocals. So cosecant, secant, and cotangent. Okay, now for sine, it's simply opposite over hypotenuse, so that's 5 over root 34. Cosine is adjacent over hypotenuse, but remember, second quadrant, cosine is actually negative, so it's negative 3 over root 34. Tangent is opposite over adjacent, so 5 over 3, but then again, tangent is negative in the second quadrant. Only sine is positive, okay? For the cosecant, secant and cotangent are reciprocals. You simply flip the fraction, so that's root 34 over 5. Negative root 34 over 3 for secant, and finally for cotangent, it's negative 3 over 5. Okay, so that's what we did last time. Basically, introduction to the reciprocal functions, or reciprocal trig functions. Okay, we have another one here. We can find the angle theta. So it says cosine theta is negative 1/2. What are the possible value of theta in the domain between 0 and 360? So right away, what I need to do is to figure out the reference angle. And I think I mentioned this, whenever you're looking for the reference angle, you always take the inverse trig ratio of the absolute value, okay? Absolute value trig ratio. So it's absolute value of negative 1/2. That's why it's only positive 1/2 here. If you put this into a calculator or not, because this is a special triangle, this you should get 60 degrees. Okay, let me just make sure. Let me draw this special triangle here. Here's 30 degrees. That's 1, 2, root 3. So that's 60. So cosine is adjacent over hypotenuse. So the adjacent side is 1, which means the angle is 60 degrees. So the reference angle is 60 degrees. Okay, now we are looking at cosine being negative. So based on all students take calculus, cosine is negative in quadrant 2 and quadrant 3. So you have two cases. Okay, so case 1, if your angle is here and the reference angle is 60, that means here's your theta 1. This is going to be 180 minus 60, which is 120 degrees. Okay, or you could have this in the third quadrant, because that's where cosine is also negative. And there is my theta 2. Again, this is 60 degrees right here. So theta 2 would then be, in this case, 180 plus 60, which is 240 degrees. So you actually have two different answers. Okay, so because cosine is negative, so it could be either in quadrant 2 or 3, depending on, which quadrant we don't know, right? But it doesn't say, so we gotta consider both cases. Now, we're only looking at the domain of 0 to 360, so we only have two answers. If we make the domain bigger, then you could find more answers by adding either 360 or minus 360, okay? So that's what we did last time, okay? So as I mentioned earlier, another unit for measuring angle is what we call the radians. Okay, so it's the radian, and this can be found on your calculator. Okay, so be careful. When we are in degree mode, on your calculator, it will say DEG on the top of the screen. Okay, so some of your calculator will say DEG, some of it will say D on the top of the screen. And if it's a radian mode, then in the calculator, you'll say RAD, or you'll simply be an R, okay? So if you need help on how to change from one mode to the other, let me know and I'll help you with that, okay? But you got to be careful. If the question is in radian mode, then when you do your calculation, your calculator will have to be in radian mode. If you're doing the question in degree mode, then your calculator has to be in degree mode. Okay, so that's the basics of it, okay? So what exactly is a radian measure? Okay, so here it says, in a circle with radius r, angle is equal to the arc length divided by the radius. Okay, so angle theta is equal to the arc length divided by the radius. So you can see the arc length a divided by the radius of r. Okay, or if you rearrange it, you can solve for a. Arc length is equal to r times theta. But this is the definition of radian measure. Okay, so angle theta, instead of measuring degrees, is actually equal to the arc length. Okay, so you can see this is the arc length. That's how long the length is for part of your circle, divided by the radius. That will give you the radians. Okay, so that's the angle in radians. So you can see on this diagram right here, if the arc length is equal to the radius, so it's saying that this length, the arc length right here, is the same length as the radius, then this angle is defined to be 1 radian, because arc length divided by radius, it's radius over radius, so it's simply just 1. Okay, so in that case, angle would be 1 radian. Okay, so let's think about in a circle with 360 degrees. What would the angle be in terms of radians? So in a circle, we know it's 360 degrees, right? In degrees, it's 360. But what about in radians? Well, all we need to do is this. It tells you here, 360 is 2 pi radians. But let's think about why. Okay, so here's a circle, and here's the radius. We know 1 full rotation, okay, that's 360 degrees. But again, we want to figure out how much that is in terms of radians. Well, again, radians, theta is simply arc length divided by radius. So given that any circle with radius r, we can find the arc length, which is simply just the perimeter, right, or circumference of the circle. And recall, circumference is equal to 2 pi times radius. So arc length for the circle is 2 pi r. And you can see if you reduce the r's, then you get 2 pi, right? So this theta is for the 1 full rotation, 1 circle. Its arc length is 2 pi r, and the radius is r, so you can see you can cancel the r's. So 360 degrees is equivalent to 2 pi radians. And this is important because we're going to use this fact to convert from radians to degrees or degrees to radians. Okay, so you can reduce this, right? If 360 is equal to 2 pi radians, then that means pi would equal to 180 degrees. Half of it makes sense, okay? So let's think about this. It says, can an angle measured in radians be greater than 2 pi or less than 0 radians? And of course, we could have more than 2 pi radians or less than 0 radians, just like we can have more than 360 degrees or less than 0 degrees, okay? Same idea, right? If you want to have more than 2 pi radians, then you simply start from a positive x-axis and you rotate more than 1 full rotation. If you want to have less than 0 radians, so negative, then you simply go clockwise. Okay, that would be negative angle, right? And this will be more than, not just more than equal to, right? It's more than 2 pi. And this will be less than 0 radians. Okay, all right, let's look at some examples here. Part A says, given that theta is 305 degrees, determine its measure in radians. Give the exact measure and its approximate value to the nearest hundredth. Okay, so we can use proportions to solve this question. Okay, so we know pi is equivalent to 180 degrees. Again, pi is equivalent to 180 degrees. We want to figure out how many radians 305 degrees is. So then we can set up the equation like this, right? Pi over 180 is equivalent to x over 305. Okay, so this is degrees, and that's why we put 305 in the denominator, because both are degrees, and then x is radians, so you can see it's on the denominator, in the numerator with pi. Did I say numerator or denominator for 180? I can't remember. It should be denominator, okay? Degrees in the denominator, radians in the numerator. Of course, you can flip them around and it doesn't really change the answer. All right, so now we can solve this. It says give the exact measure and approximate the value. So we can solve for x. Recall, we can cross multiply. So 180x should equal to 305 pi. You can solve for x by dividing both sides by 180. So that will be the exact value. You can reduce this. You can divide both by 5. You should get 36 and 61. Can we reduce this even more? I don't think so. So that will be the exact value answer. If you want to approximate the value, then you simply put it into your calculator. Okay, so 61 times pi. Where's the pi button on the calculator here? Right here. And then divided by 36. You should get 5.32. Okay, so 5.32 radians. Okay, the radians we just write rad. Okay, degrees we use the little circle, right? So radians you write rad. Okay, so that's part A, converting from degrees to radians. Part B, we are gonna switch. We're gonna go opposite. Gonna go the other way around. Okay, we're gonna go from radians to degrees. But part one says sketch the angle in standard position. So we know how to draw angles in standard positions for degrees. Now for radians, I have something to show you. 0. 1 for rotation, we know it's 2 pi, right? 180, we know that's pi. Okay. Now 0 to pi, remember this is halfway, right? 90 degrees is halfway between 0 to 180. So this is halfway point between 0 and pi, so that's going to be pi over 2. This is the halfway point between pi and 2 pi. So if you write pi as a fraction, we can write it as 2 pi over 2. This is 1 pi over 2. So this one is going to be 3 pi over 2, right? Because 2 pi is the same thing as 4 pi over 2. So notice how each time you move the quadrant, it's going to be 1 additional half pi. Okay, so now we're looking at negative 5 pi over 6. Okay, so it's negative angle, so we know we're going to go this way. We're going to go clockwise. Okay, so part 1. We know we're going to go this direction. Now, negative 5 pi over 6 is not quite, so again, each quadrant is pi over 2. So this from here, if we go backwards or clockwise, this will be negative pi over 2. And that will be negative pi, right? Because negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, and so on. So this is negative pi over 2. But our angle is negative 5 pi over 6, which is actually, if you don't look at a negative sign, if you just look at 5 pi over 6, it's more than half pi. But it's not quite 1 full pi. So we know the answer or the angle is going to end in the third quadrant. It's going to be right here, somewhere here. This will be negative 5 pi over 6. Again, because this negative 5 pi over 6 is more than negative pi over 2, but less than negative pi. And we know negative pi would be exactly right here, right? So, so it's going to be in between those two axes, okay? The negative x-axis and the negative y-axis. Okay, so that's part 1. We draw the angle in standard position. Part 2, we want to figure this in terms of degrees. So then, just like what we did there, pi over 180, this is your conversion factor, basically. This is how you convert. Now, this time we're given radians. So now I'm going to write negative 5 pi over 6 on the top and x in the denominator, okay? Because that's radians and pi is radians. So now again, we can cross multiply. So pi x is equal to negative 5 pi over 6 times 180. To solve for x, you divide it by divided by pi on both sides. So then you get we can simplify this too. That's 1. That's 30. So you end up with negative 150 pi divided by pi, right? Because we need to get rid of this pi, so you got to divide both sides by pi. You can see that cancels out. You get negative 150 degrees as the answer for negative 5 pi over 6. Okay. Lastly, here, given that given theta is 6.55 radians. So notice this time theta is 6.55. It does not have to be written in terms of pi. Okay, radians is again it's just an angle, so it's just a number. Okay, but we don't need to write it in terms of pi. So given that theta is 6.55, we're looking for this in terms of degrees. So same thing, pi over 180 should equal to 6.55 divided by x. So pi x is equal to 6.55 times 180. Therefore, x is 6.55 times 180 divided by pi. Put this into calculator. We should get 375.3 degrees. Okay, so hopefully this is not too difficult for you right now. Okay, what's more difficult is yet to come, but hopefully you can try these 3 questions on your own for the practice, and I will show you the answer in a bit. Okay, good luck. All right, so hopefully these are the answers that you got. Okay, so the only thing I want to comment on is part B. So make sure you check your answers first of all. But for part B, again, that's negative 12 pi over 11. So again, the way I do this is I don't even look at the pi. I just look at 12 divided by 11. This is more than 1. So again, we know each time we move a quadrant, it's going to be 0.5, right? So that's negative 1 point something, but not quite negative 1.5. So this will be negative 0.5, that will be negative 1, that will be negative 1.5, but again, it's not quite negative 1.5, right? 12 divided by 11, it's 1 point something, not very big. But it's going to be in the second quadrant, okay? Because between negative 1 and negative 1.5. Don't worry about pi, because we know pi is going to be there with us when we move the quadrants, okay? Each time it's half of pi, pi over 2, pi over 2, pi over 2, and pi over 2. All right, moving on. Reminder, when determining a trig ratio for an angles in radians, make sure that you set your calculator to radian mode. Okay, so again, I mentioned this earlier. This is important. Okay, make sure you're in radian mode. So part A, it says determine the exact value of cosine of negative 11 pi over 3. So anytime it says determine the exact value, it's going to be one of the special angles. Okay, so let's draw the special triangles now, and let's change it to radians. Okay, so we have 30 degrees. Then let's write it down in degrees first. 30 degrees, 60 degrees. It was 1, 2, root 3. And the other one is the 45, 45. Okay, so 45, 45, and 90, that's 1, 1, root 2. Okay, so now we're going to convert those angles, 30, 60, and 45, into radians. Okay, so again, by using the same procedure, I'll do one here. 1 pi over 180 is equal to x over 30. You should get 30 pi is equal to 180x. So x would be 30 pi over 180, which means it's pi over 6. Okay, so 30 degrees is actually pi over 6. Okay, you can do the same thing for 45 and 60, and you should get pi over 3 and pi over 4 respectively. Okay, so I'm just going to write it down. Oops, what did I do? Okay, I guess now I need to redraw it. That's fine, not a big deal. 1, 1, root 2. This is now going to be pi over 4 and pi over 4. All right, so now cosine of negative 11 pi over 3. And 11 pi over 3 is actually one of the special angles, okay? So we need to find the reference angle first. So if we draw this, okay, so again, like I said, I don't worry about pi. I just go 11 divided by 3. And I know 11 divided by 3, this is about 3.3 repeating, okay? So starting from the positive x-axis, because it's negative, so we're going to go this direction. That's half. Okay, again, we don't need to worry about pi. That's 0.5, 1, 1.5, 2, 2.5, 3, and now this would have been 3.5, but again, we want to end with 3.3 repeating, so it's going to be right here. Okay, 3.3, it's going to be right there. So we know 11 pi over 3 is going to be right here in the second quadrant. Okay, and now we can figure out the reference angle. This right here. All right, so now we said this was 11 pi over 3, which means we got to go 3 pi over here, and we'll have a little bit more. Okay, so 3 pi, we know 3 pi is going to be 9 pi over 3, right? So 3 pi is equivalent to 9 pi over 3. This is 11 pi over 3, which means we need to go 2 pi over 3 more. Yeah, that's right, 2 pi over 3 more. 2 pi over 3, like this. Okay. All right, I made a mistake. 11 over 3 is not 3.3 repeating. It's actually 3.6 repeating. No wonder 2 pi over 3 doesn't sound right to me. Okay, so it should be 3.6 repeating. So then that just means that, again, we said that that was 3.5 over here, right? So that's 1, 2, 3, 3.5. So 3.6 repeating will be right there. So it's actually first quadrant, my bad. Okay, so it should be here. And we know this is 3.5 pi. Okay, 3.5 is the same thing as 3.5 pi, and we have 3.6. So this is simply pi. Okay, so I'm gonna go 3.6 minus 3.5. This is 0.16 repeating, right? Which is pi over 6. Pi over 6, yes. Okay, that means, or you can think of it this way. If this was 3.6 repeating, that means the rest here will be 0.33333 repeating, which means this is going to be pi over 3 right here. Okay, that's going to be pi over 3 right there. So then you can look at your special triangle. Pi over 3 is right there, so the opposite side is going to be root 3. Hypotenuse side is going to be 2. Adjacent side is going to be 1. If we're looking for the cosine, it's going to be adjacent over hypotenuse. So adjacent is 1, hypotenuse is 2, 1 over 2, and that's it. Okay, I will show you one more with part B. Okay, again, these could be challenging. Okay, we'll see. Secant 5 pi over 9. So first of all, secant is 1 over cosine. So be careful. This is a common mistake. Okay, don't do this. This is not the same as cosine of 9 over 5 pi. Okay, you don't flip the fraction for the angle. Okay, that's an angle. You can't flip it. What you're flipping is secant is 1 over cos. 5 pi over 9. Okay, like that. Okay, so be careful. Now, this time it says we want to determine this to the nearest hundredth, which means this is not a special triangle, so really all you can do is put this into calculator. Okay, so that's what you need to do. 1 divided by cosine of 5 pi over 9. Be careful, you should be in radian mode. Okay, so make sure you're in the right mode, because I am not in the right mode right now. Let me change it to radian mode. Again, if you need help changing the modes, let me know. Divided by 9. This is going to be negative 5.7 near hundredths, so 5.76. Okay, so there are 2 questions here for you to try. Good luck. I will show you part A for sure, and then part B should be easy. Okay, good luck. All right, for this one, negative 3 over 4. Again, we don't need to worry about pi. It's negative 3/4, which means it's more than, or I should say less than. But anyways, if you just think about the 3/4, 0.75 is more than 0.5, but less than 1. Okay, negative sign just means we're going to go clockwise. So more than 0.5 means we have to go through this quadrant. We're gonna finish the 1 quadrant, and then we're gonna go more, but not quite till the second one. Okay, so because that will be 1. But this is 3/4, so 0.75 is right here. Here is negative 3 pi over 4. That means we can find the reference angle that's right here, this one. So it's 3/4, but we need a little bit more to get to 1 full radians, right? Or 1 full pi radians. So this reference angle is going to be pi minus 3 pi over 4, which is going to be pi over 4. So this is pi over 4, and you can see pi over 4 is one of the special triangles here. It's 1, 1, root 2. So 1, 1, root 2. Now, if you're looking for tangent of negative 3 pi over 4, tangent is positive in the third quadrant, so the answer will be opposite of adjacent, which is 1 over 1, and which is just 1. Okay, so be careful here. The angle actually end up in the first quadrant, so cosine will be positive as well, right? So that's why I didn't actually mention it, because everything is positive in first quadrant. Okay, so I think locating where the angle is important, and that could be a little bit challenging at first. Again, it just needs practice. Okay, practice makes perfect. All right, moving on to example number. Here's the answer for part B. Hopefully that's what we got, 2.61. Okay, so simply 1 over sine because it's cosecant. All right, example number 3. Let's see here. It says an approximate model for the motion of the International Space Station is that it travels at a speed of 27,600 kilometers per hour in a circular orbit at an altitude of 400 kilometers above the surface of the Earth. The radius of Earth is approximately 6,400 kilometers. So we have the Earth, and we have the space station over here. Okay, and it says visualize a line segment joining the space station to the center of Earth. So here's the center of Earth right here, vertical line. Okay, the altitude is 400, and we know the radius of the Earth is 6,400. So that means this length is going to be 6,800 kilometers. And to the nearest tenth of a radian, through which angle will the segment have rotated after 40 minutes? So it's going to rotate for 40 minutes. Okay, now we are looking for this angle. Now we can find out the arc length because we can figure out how far it traveled because it tells us the speed and the time, right? So we can find the distance by multiplying the speed, which is 27,600 times the time, 40 minutes. So be careful. This is hours, this is minutes. So you got to make sure you convert minutes into hours. It's 40 minutes out of the 60 minutes in an hour. So that would be the number of minutes, or that's the distance that it can travel. I think this will give us a nice number. We can divide this by 6, that's fine. 460 times 4 is 1840 kilometers. You know, I'm just going to put it into calculus just to make sure, because I did 11 divided by 3 wrong. So as I get older, I have less confidence in my multiplication. So yeah, okay, 1840 is right. So we know the arc length is 1840. Okay, so now we can use the formula that we had earlier here, right here. A is equal to r theta, or theta is equal to arc length divided by radius. Just remember one, because you can always manipulate. I always like to memorize the one that's multiplication because it's easier. A equal to r theta. Okay, it doesn't matter which one you try to remember. Okay, arc length is 1840. Radius is 6,800, and we can solve for angle theta. And you can simply put this into calculator. We need to round to the nearest tenth, so we go 1840 divided by 6,800. This is 0.27 radians. Okay. Now I should mention this: when you want to use this formula, make sure your angle is in radians. Okay, so to use this formula, angle has to be in radians. Okay, so the calculation, the answer that we got is also in radians. Okay, continue to the nearest 100 kilometers. What is the straight line distance? Okay, we know we're gonna skip this question. You need to use cosine law. I don't know if you know what. I'll do it just in case if you want to figure out, right? So we have this shape, and we know this is 6,800. This is 16,800. We found the angle to be 0.27. We want to find the straight line distance. Okay, so by using cosine law, if you remember, it was c squared is equal to a squared plus 8 squared minus 2ab. So 2 times a times b cos c, which is 0.27. Okay, so now you can put this into calculator. So 6,800 squared, 2 of them, minus 2 times 6,800 squared times cosine 0.27. You get x squared is equal to 3,350,467.504. And now you square root this. You should get 1830.4 kilometers. Okay, so that's the straight line distance that it traveled from one station to the other, or from the original position to the new position. Okay, So again, you need to use cosine law in this case. All right, example 4, so 2 more questions here. It says the point P, negative 2, 5 is a terminal point of the angle theta in standard position to the nearest tenth of radian. Determine the possible values of theta in the domain from negative 2 pi to 2 pi. So this really gives you the question away, or give you the hint that your calculation should be in radians. You can see it's not from negative 360 to positive 360 degrees. It's from negative 2 pi to positive 2 pi. Okay, so let's draw the triangle first. As always, negative 2, 5 is somewhere here. So this is 2, that's 5. We can find the hypotenuse side easily by using Pythagorean theorem. I will skip that step. It should be 5 squared plus 2 squared, so root 29. We're looking for possible value of theta. So again, okay. So what we know it's in second quadrant. Okay, so here's angle theta. So we actually don't need to find hypotenuse, I suppose, because we can find the reference angle. Tangent theta should equal to opposite over adjacent. So 5 over, or negative 5 over 2. Okay, 5 over negative 2, same thing. Okay. Now we can find the reference angle. Again, tangent is negative in second quadrant, right? That's why I have negative 5 over 2 here. You can find the reference angle by taking the inverse tangent of 5 over 2. Again, anytime you're looking for reference angle, always use the positive ratio. So 2.5. This is 1.1 nearest 10th, so 1.2 radians. Okay, so clearly theta is not going to be 1.2 because 1.2 is the radians. So to find the angle in degrees, we usually, if it's in the second quadrant, we go 180 degrees minus the reference angle. In radian mode, same thing, right? But instead of 180 degrees, we take pi, because pi is equivalent to 180 degrees. We take pi and then minus 1.2. So you go pi minus the answer. That would be 1.95, which is 2.0 radians. Okay, and now because we're looking at between negative 2 pi and 2 pi, we now can find more answers. Again, remember, we just need to find coterminal angles, which means we either add 2 pi or minus 2 pi. But we are already at 2.0. If we add 2 pi, it's going to go beyond our domain. So what we need to do is we need to take 2.0 and minus 2 pi. Take that, but be careful, don't actually use 2.0, right? Use the answer function on your calculator and take the answer that you got, minus 2 pi. You should get negative 4.3 radians. Okay, so these are your answers. Okay, finally part B. Last question here. Given secant theta is 1.3, so if secant theta is 1.3, remember that means cosine theta is equal to 1 over 1.3. To the nearest tenth of a radian, determine the value of theta in the domain from negative 2 pi to 2 pi. So again, this time it tells us cosine is positive. And unlike part A, where we know where the angle is, this time we don't. So we need to consider 2 possible cases. It could be in quadrant 1 or 4, right? Because cosine is positive in quadrant 1 and 4. So what I'm going to do right away is I'm going to find the reference angle. The reference angle is the same regardless of which quadrant it's in. Okay, so quadrant reference angle is going to be inverse cosine of 1 divided by 1.3, which is going to be 0. We are solving to the nearest 10th, so 0.7. Okay, so that's the reference angle. So case 1, this is in quadrant 1. Well, in that case, theta 1 is exactly the same as the reference angle, right? Because here is the first quadrant, that's the reference angle, and that's the angle itself. And now again, because we're looking at the domain from negative 2 pi to 2 pi, we have one answer, 0.7, but if we add 2 pi, we are going to go outside of the domain, so the second answer will be 0.7 minus 2 pi, and you should get negative 5.6. Okay, so that's your first answer. Here's your second answer. Now we can work with case 2. In that case, we're looking at quadrant 4. So here is the angle theta. We know the reference angle is 0.7. So the third answer is going to be 2 pi minus 0.7. Again, if we are working in degrees, then we take 360 minus the reference angle. But since we're in radian mode, so we take 2 pi instead. So let me just get a reference and go again back into my calculator, inverse cosine of 1 divided by 1.3. Okay, now I have that number in my calculator. I'm going to take 2 pi minus the answer. That should be 5.6. And now, again, if we add 2 pi, it's going to go way beyond 2 pi. So instead of adding 2 pi, we're going to minus 2 pi. And you're going to have to keep adding 2 pi or subtract 2 pi until you go outside of the domain, okay? Yeah. So you're going to get negative 0.7 out of that and positive 5.6 for your case 2, which the angle is in quadrant 4. Okay, so I think the most difficult part of this might be just getting used to work in radians, because that's something new and might not be as straightforward as you think. So just get your brain used to it and you'll be fine. Okay, you'll be okay. All right, so there are questions for you to practice. Let me know if you need some help. Okay, otherwise good luck. See you.